This is group 34. We're called the Quad. We have Raymond, we have Steven, me, and there's another Raymond also. We are dealing with the traffic sign detection and recognition system. That's our topic. And then the problem under investigation is we are coming out with an application that will address the lack of knowledge about the use of the meaning and interpretation of traffic signs. It will be translating the meaning, and most especially will be notifying the novice drivers who are in real time across the roads, and this will minimize them in correcting, also in minimizing causing accidents. The background of our study will be dealing with ensuring traffic safety, development of smart cars, which requires detection and recognition of traffic signs. We'll be using an algorithm from the CNN model, also a technique from the Gerber-Mist canal, followed by a normal convolutional canal after the pooling layer. It will give an accuracy of about nearly 99%. Then our significance will have one of them is to minimize accidents. We have improving driver assistance programs. And then with the aid of maintenance of traffic signs, we'll use a scanning data for spatial related inspection instead of having to do it manually. We'll also have a system which will provide a basis of research and inspiration to fellow scholars, which will improve systems that will fall in the same technology trust of it. The application will also be used to collect data, and purposes of this search will be a similar technology cooperation. This is our scope. We have a geographical methodology and then the technology. The geographical will be dealing with our model, which will have the road signs around Kampala, of course, the CBD, and then we'll be catering the most, in our case study, the most used roads or the most picked up roads, which have the similar road signs that we are going to be using. Our methodology will have the most signs that are used. We have the U-turn, speed limit, no parking, one way. And then for our technology, we have a laptop and a phone with an interface to support our system. The person will be using the phone camera to detect, and then data for interpretation. Then the statement of addressed problem. We've come about to our notice that some few novice drivers on the road in Uganda, they could be ignorant sometimes, and also they cannot interpret the signs properly due to maybe certain hardships, or maybe they're not even familiar with them. So we're going to do a few interviews, and which will contribute a lot in our data collection. And also some of these people contributed in a lot of corruption and incompetence in public entities and governing bodies in charge of regulating road use. We also have an instance where someone on the road makes an illegal U-turn and runs a stop sign. This person doesn't know how to drive, most probably, and isn't experienced maybe in certain roads, maybe has been seeing them and maybe doesn't need to interpret them. Whenever this happens, someone's life, whether a pedestrian or cyclist or maybe a motorist or the boda, is potentially at risk. So we should rethink our level of importance. Research questions. We have how the presence of road signs impacts the number of accidents on the road. Number 2, the novice drivers know how to use and interpret road signs. Number 3, are people trained or sensitized about the significance of road signs during the process of acquiring the necessary permits for driving? hypothesis, where we are testing if yes or if no, whether a model for novice drivers or inexperienced road users that detects, processes, or interprets traffic signs from images in real time can reduce accidents and make driving more convenient. So this is what we are processing about. And then our research objectives, our main objectives, particularly mainly, is to develop a machine learning model in form of an application to assist drivers for detecting and interpreting signs. This will help them in the real time on the road. And also remember, most when they're using the road, interpreting the signs. Then we have specific objectives whereby we're going to be defining the user requirements used in implementing the traffic, design and develop a system, implement the model, and then to test and validate the system upon the completion and ensure that it works efficiently and fulfills them most of our objectives. Our Gantt charts, this is what processically will be happening. First 3 months we'll have the requirements. Second to 6 months we'll be analyzing our data. Designing is now the real thing. Month 2 to month 5, then the coding part, 4 to 7, then testing 6 to 8, implementation month 5 to 7, and then last month we'll have a presentation of our project. Our methodology will consist of the requirements analysis, of course, according to the Gantt chart. Requirements analysis, design, coding, testing, implementation. Implementation now is the practical part. The following are the references from which we'll be seeking some of the data from. Research and application of traffic sign detection from Wang Kanyong. Then from Juan Senyan, we'll be having the road traffic signs detection, recognition in natural scene, and then the rest. The rest are also references. We're giving the following will be giving credits to. That's number 1, and the International Journal of Engineering, Research and Technology, FeedCodecamp, Patek, Solutions.hub, Nosh.com, on YouTube. Those are the following authors in terms of CNN, which is neutral networks, and then deep learning.